Welcome everyone to our April webinar, and we're trying to keep these things seasonal. So as we head into the end of the spring and into summer, we're getting into demand response season. And so today we're going to talk about a very timely topic. We've got some great speakers lined up for this conversation around dynamic load management, demand response, load shifting, and how does this overlap and intersect with energy efficiency, energy management strategies? How can we combine incentives? How can one hand, wash the other? And so I think it's going to be a really interesting dynamic conversation, and encourage folks to jump in with questions. We're going to try to save some time for that at the end. My name is Dave. I'm the founder of Sustento Group. We run the LA Better Buildings Challenge, and I can't believe, gosh, we're doing this for over a decade now. So this is a fun job. I love my work and look forward to the conversation today. As always, want to thank our funder, a sponsor, the LA Department of Water and Power, for their continued support of this program. And we're going to have two great speakers from the department on today. Quick housekeeping items as usual. We'll keep things orderly by keeping lines muted, but please do submit your questions through the chat and we'll get to those at the end as time allows. We will be recording today, so hopefully that's cool. And we'll be sending around a copy of that along with key takeaways, the slides, and some other resources that we'll touch on as we go through here today by Friday. And we appreciate your feedback. So we're going to try to remember to send through a little survey so we can do more of what you like, less of what you don't. So thank you for any feedback and questions that you may have. I touched on this, so this is going to be conversational, right? Keeping the ideas kind of flowing and building. But to provide a little bit of order of operations here, I'm going to set a little context, introduce our speakers, then we'll hear from the LADWP demand response program, because we are heading into DR season as things start to warm up. Then we'll hear about related synergistic efficiency programs, how these things can be combined, some context for the department, where their priorities are, and then the customer perspective. How is this working in practice? What have been some of the results achieved thus far? Lessons learned, opportunities, and then ideas that come out of this conversation, because this is still new, right, for a lot of folks. And then free-flowing discussion and looping all of you in, audience members, to get your questions in there as well. So a bit of context. The IPCC, the Intergovernmental Panel on Climate Change, used to only release reports every year or two. You may have noticed, scientists chaining themselves to banks and things like that lately, because it's urgent, right? We are feeling it right here locally, but the data are so clear, and you only have to look outside to see that this is real. It's time to move. And really, as we talk about DR and efficiency, we're in adaptation now, and DR, load shifting, and efficiency with that is an adaptation strategy, right? In a way that large buildings can really contribute and lead and create some cover while we work on other solutions as part of the solution set. Just continuing on the urgency, and not to get too doomy, but it's important to remember, right? The news cycle is fast. We are in a massive drought. Some of you may have seen an announcement that came out yesterday, but new water restrictions are in place, and we don't see those going away, right? This needs to be a way of life. And FEMA, the federal agency that supports after natural disasters, does risk assessments nationwide of where are the risks the greatest. And here we have a dubious distinction. LA County, not the city per se, but LA County, number one out of 3,000 that they look at when you look at all the different risks that FEMA is concerned about, wildfire being at the top there, as we have these memories still fresh, and we're in a drought, a continued drought yet again. And of course, maintaining the foliage and undergrowth around power lines is part of this, but overstraining power grids causes sparks, right? And so we want to do all we can to reduce those loads and shift those loads. Another area where LA is leading, though, on a more positive note, one that to be really proud of is on solar. Right, LA is leading the nation in solar, and that's thanks to huge investments by DWP, but also by the private sector, who is stepping up and building projects, entering into long-term agreements, and we're seeing more and more of a push for this. I was reading something about from the corporate sector as well, pushing for improvements to tax credits, and DWP ranks #1 in municipal utilities in the nation, and I believe regardless of investor-owned versus public in terms of the dollar value, the size of its solar incentive program. So something to really be proud of. But when you look at, and this is not it's just a fact, right? Load curves are changing, and they don't match up super well with when the solar resource is the strongest, which is right during the day. So we've got large buildings kind of firing up in those early morning hours to pre-cool, get ready for the day. We'll be talking more about that, obviously, in today's conversation. And then when people get home from work, flip on all the lights, flip on Netflix, whatever, you see that peak. And so how can we shift loads? How can we store energy? I don't know that we'll get into storage today, but that's a huge topic. So that this clean solar energy is available at the times we actually need it, right? And we're not having to curtail it, which is just a sort of a frustrating problem to have. And I touched on this, but while we see great investment in renewable energy, solar and wind and other sources of clean energy starting to come into the conversation, loads are increasing. Some of that's good, some of it's not good. I'd say that, good increase, and David will talk about this, is beneficial electrification, right? Electrification of transportation, electric cars, seeing costs come down and new models coming online. Competition is heating up in a really exciting way in the automotive field. And then also just demand, the number of devices, the intensity and types of use, data centers, right? Entertainment are driving that as well. And so we see customer demand for electricity increasing, not decreasing. And so how do we do this? Again, as multiple parallel shifts happening towards more renewable energy at the right time of day, and being very, very efficient with the energy that we do need to use during those peak times. And of course, we are feeling higher temperatures due to climate change. So like I said, we're in adaptation now. We're not in sort of avoiding it, it's here. And we are, there's an equity issue, right? We've got a lot of folks that don't have air conditioning that need it in the summer. And so how do we accommodate that? And as we look at a building performance standard, as we've talked about on our February webinar with the mayor's office, that's looking to electrify more end uses in buildings, and that's adding load too. And so again, this is a lot of parallel pieces moving, demand response and retro commissioning and other sorts of smart operating and maintenance moves will be really helpful in making this a smooth process. So with that, I will stop talking for a moment and start introducing our speakers. I really appreciate all of you guys making the time. You guys are super busy, and but I think this is going to be a very fun conversation. So first we have Hassan Motalebi. He's the Demand Response Program Manager. He's been with DWP for a couple of decades and really there since the inception of this program as a concept. So really appreciate having you back again, Hassan. We have David Jacot, who is my friend and Director of Efficiency Solutions. So he is in charge of both energy and water efficiency incentives, and also looking at, as the department transitions its lens towards more decarbonization focus, electrification, and these other new ideas fall under his group. And then providing the customer perspective, I'd like to welcome back Celso Bárcena from Heinz. He's just a rock star. He's been doing this a lot longer than it looks like he's old enough to have been doing, and he's going to share some great case studies about how this all comes together at the building level, and then we will all talk. And encourage you guys to again ask each other questions and build and take it in different directions. So first, though, we'll hand it over to Hassan to walk us through the demand response program. And you guys have some big targets this year. So appreciate having you on today, Hassan.
Thank you, David, for organizing this event, giving us the chance to discuss our DR program with our customers today. Also, let me thank our DR partners that might be in the audience today. Many of them have been with us since the very beginning of the program in 2015, and also other customers that are in the audience that are potentially our future DR partners. And now, let me very briefly let me start with a definition of DR to begin with, then we expand on it. What is demand response? The most common definition you see for demand response is the change in electric load, reductions, shifts, or even, yes, increases. We're not doing that now, but that could very well be a part of this program in the future in response to market or system conditions. Now, also, what we internally refer to demand response sometimes when we get technical, we call it a smart resource load management strategy. Basically, we're trying to match the resources we have to the load. No more, no less. That's ideal. That's not going to happen. But the closer we come to this, the more efficient grid we'll have. More efficient, clean, and cost-effective. Now, if you could go to the next slide, please. Now, DR, like any other programs, has some prerequisites. At this time, it appears that our commercial customers that we refer to as major accounts are the most fit customers for DR because of certain requirements for load curtailment and having the right equipment for it. Number one on the list is the metering. You need to have an AMR meter, and most of them have a prefix. That's how you know what you have, AP or 1 AP. This is a meter that we can pull and remotely download data. For DR, we need to be able to do this in order to calculate your performance, and your incentives are based on that. Now, if you have any doubt what kind of a meter you have, that's where you look at on your bill, or you could talk to your customer rep. Actually, you have an account manager assigned to you by DWP. They have all that information for you. Number two, you need to be a CNI customer, a commercial and industrial customer, because of the next step that you need to be able to shed at least 100 kW of load to be able to effectively participate in the program. And that is mostly because you want this to be beneficial to you as well. Among many other benefits, you earn incentives. So with 100 kW, you can earn enough incentives in some cases to offset the cost you have to invest in order to be able to do this. Now that 100 kW is near minimum. Many of you have been able to do much more than that. You've started with 100 kW. Later in a year or two, you work your way up to 1 megawatts. And we have a couple of those on our program. Once you do this for a while, you get better at it, then you realize there's more savings opportunities in terms of load and load management, and you apply that. You also need to have an energy management system. This is what will enable you to automatically adjust your load, so it is not labor intensive. There are a few that can do that without a building energy management system because they have a concentrated load. They can assign someone to run around the plant, turn the switches on and off. But most of you, based on what we've seen, have a building energy management system that you're able to program it and have it do it for you to stage down the load and stage it back up when the event is over. Next slide, please. Now, how does the program work? We know the prerequisite. We know what this program does. Let's start with the commitment. We talked about it. It's a 100 kW minimum. That's, again, bare minimum. You can start with that, and you can adjust it up as you do more events and find your true potential in load curtailment. Number 2 is the notification period. You get to choose whether you want to be notified 2 hours in advance or 24 hours in advance. Then that's, again, minimum. We're not talking about exactly 2 hours or 24 hours. But once we know we're going to have an event, we immediately notify you within, couple hours or so. For example, if we're going to have an event tomorrow at 1 o'clock, most likely you would have been notified by 8 or 9 a.m. today. Then we check with you again by tomorrow morning to see if you'll be able to participate in the event or not. We get your confirmation. Now, next is the incentives. This is actually a very important part of the program. This is when you know how much incentives you earn by participating in the program. There are 2 types of incentives we offer to our customers. One is capacity, which is either $8 or $12 per kW, meaning that we measure your performance and average over the few hours of an event. Then at the end of the season, we take that number, we multiply it by 8 if you're a 24-hour advance notice, or by 12 if you are a 2-hour advance notice participant, which you choose which one to be depending on your operations and how much advance notice you need. Then we multiply it by 4, the number of months in a DR season. On top of that, we pay you energy incentives. That's the straight across the board incentives paid at the rate of 25 cents per kilowatt hours. There is no minimum there. We just count the kilowatt hours you save, and we pay you 25 cents per kilowatt hour. DR season starts on June 15 and it ends on October 15 of each year. Those are the hottest months we have, where we expect the load to be high. And also that's when we need that curtailment, the peak load curtailment the most. Now, that's a 4-month season, and incentives are capacity incentives are based on that. Then you might want to ask how many DR events we're going to have. The maximum is 12. So far, since 2015, we have not called for 12 events. I believe the most we have called for has been 8. The least has been 3. But we need you to commit to 12. Events are from 1 p.m. to 6 p.m., and the duration will not exceed 4 hours. So any up to 4-hour event between the hours of 1 p.m. to 6 p.m. during the season. For a 4-hour event on a day in the month of July could be 1 p.m. to 5 p.m. or 2 p.m. to 6 p.m. Just one event per day. Well, if it's a 2-hour event, it could be any combination of those hours between 1 to 6. Next slide, please. Now, what measures do you need to take in order to curtail your load when we ask for it? What I have here is a list of the measures that you have told us you've done. We have another list that what is suggested pretty much matches this, but when we talk to our customers through surveys, when we ask them what measures they've been taking to curtail their load, this is the feedback we've received. For example, on the top, elevators are one of the measures they take. If you're in an office building, you have 4 banks of elevators. Some of you choose to shut down 1 or 2 of them. So there is some savings there. Some do air handling units. They modulate those. or the cooling load, whether it is adjusting the temperature or the chilled water temperature, the thermostat sitting in the building, or some of you choose to do pre-cooling on the day of the event between maybe 5 a.m. to 9 a.m. to bring down the envelope, the chilled water, temperature, to use that later on when the event is in effect. Some pick the lightings in the garage. If you have the type of the building energy management system that allows you to turn some of them off every other row or every third row, there is savings there. Some of you dim those lights if you have that capability in your energy control system. Exhaust fans, most of them we've learned are on CO2, basically controls. CO2 indicators decide when they come on, or the sensors, or either get turned off. Some are done manually. So some of you have been able to turn those off for a couple hours a day. And also, some of you have told us that you even turn off the toilet fans and all that. We don't recommend that, but if it works out with your, you in a shop, if it works out with your system, it's your call, whatever you choose to do. Escalators, parking garages, some of them, like at LA Live, have escalators. Some choose to do that. We talked about the dimming the lights we talked about, and equipment processing delay, that's mainly shifting your load. If you have a batch processing, some factories do that. They shift it to the different time slot, and within that time slot, they turn off that machine or that equipment or that process. If you have water features and other things in your building, some choose to turn that off when there is an event. Plug-in load, some people choose to do that. And we talked about the most common one is the global temperature set point. If you adjust it up by 2 or 3 degrees in an office building, you have a lot of savings there. Next, please. Now, this is what we've done so far with DR. We started in 2015 with a pilot program. We were able to sign up 28 customers. If you're in the audience, we probably met face to face. I didn't have as much gray back then, but I assure you, these are not, the gray of distress. These are gray of happiness. I very much enjoyed working with you. Back then, we were able, as the first time, many of you signed up for the program with the minimum of 100 kW because we were learning from each other back then. We were not sure what the potentials were. 112 megawatts, we were able to curtail that year. We had 4 or 5 events. We paid only about $50,000 in incentives. And over the years, we've worked our way up to 58 customers in excess of 30 megawatts or 32 megawatts. And last year, say in 2019, we paid over $1 million in incentives to our customers. Last year, we saved, in 2020 or so, we saved about 658 megawatt hours. It has gone up as we've done this more often. We've gotten better at it. Savings are higher and portfolio is higher. There was a slowdown in 2020 and 2021 a little bit because of COVID, but we're coming around the corner on that. We're hoping to sign up more customers this year, and we hope that the trend would be upward beyond this point. To date, the savings due to DR has been over 3,000 megawatt hours, and we've paid close to $4 million in incentives. Some of our DR customers earn in excess of $100,000 a year in incentives for participating in DR. Next, please. Now, how to partner with us in DR is a very simple process. We recommend that you first contact your key account manager at LABBC. They're very knowledgeable about this program, and they have all the information, initial information you need. Contact them, request a DR document package. Within that document, you get an application form, terms and conditions, some Q&A, document, the most common questions you might have. And if that is enough for you to join the program, at that point, you can sign the application, give it to your account rep. He or she will send it to us. Then we set up a meeting and have more discussions. If you have questions beyond that, you can request a meeting with the DR team, either me, myself, or a member of my team will meet with you face-to-face, or now we do webinars and answer your questions. And after your questions have been answered, then at that point you can fill in the application and give it to us. And if you still are in doubt how much commitment you need to make in the beginning, we recommend that you put down 100 kW because we're certain most office buildings in our service territory are capable of doing that, more than capable. Usually 250 and 300 kW is what most office buildings are providing now in terms of load curtailment, average load curtailment. You put down 100 kW and we wait until the next DR event. Then we can measure it actually, give you actual numbers of what your potential are, and we allow you to adjust it. If you say 100 kW after the first event, if you want to go up to 200, 300, we let you do it. And we treat it as if you signed up for the program with that higher number from the very beginning. That way you don't lose any incentives due to miscalculating your DR potential. So this is intended to encourage you to join the program and help you participate with your maximum potential. Next slide now. Now, DR team at this point, actually, Linda is missing here. We have 3 members with a new member we have. Some of you might know that DR has 2 components, commercial and residential. We're not going to talk about the residential part of the DR. We launched that in 2020. It's a completely different program. ZA is assisting me with managing the CNI and the residential. Also, we have Linda Novoa. You may have talked to her from time to time in the past regarding the CNI program. Linda specifically manages the residential part of the shop here for DR. But both Linda and ZA are well-versed in both commercial and residential, and either one of them can answer and address your questions or meet with you to go over your applications. But specifically, ZA is assigned to CNI and Linda handles the commercial. And on that note, I want to thank you for your time. I tried to be as brief as possible. And if you have any questions, I'll be glad to answer those questions. Thank you, Dave.
Thank you, Hassan. That was great. Yeah, and I love this program because you guys are so accessible, you know, and it's a low barrier program. It's flexible. You know, there's generally speaking no, you know, out of pocket cost. There's no construction, right, that's happening. This is all about, you know, finding ways to operate the existing plant and equipment differently, maybe. And I just wanted to underline, as we now transition to David Jaco on the efficiency side, that some of the measures that were listed on your DR slide are also measures that are incentivized through custom performance program, which is in David's shop. So the opportunity here to you know, combine incentives, but of course, to get the efficiency incentives, we need to have some projections, right, of what are the expected results going to be. So we'll get more into that, but just wanted to call out that overlap as we hand it over to David Jaco, Director of Efficiency Solutions.
Thank you, Dave. Welcome, everybody. I'm David Jaco, Director of Efficiency Solutions. I run our energy efficiency programs, but I also do a lot of coordinating of those programs with our other offerings within the department for mutual benefit both to us and to you, our customers. I'm going to talk a little bit about energy efficiency first, and then how we're using energy efficiency specifically to support our demand response efforts both now and in the future. DWP looks at energy efficiency as a supply side resource. What that means is energy efficiency is put on par and judged alongside other more traditional ways of generating electricity, whether it's renewable generation or our steam plants, our natural gas steam plants, or imported hydropower, et cetera. And we do that for a couple of reasons. One, we see it's a good way to help our customers save energy. You know, instead of having to buy power, they can save it. That's first and foremost. But from a system standpoint, for us as a utility, we know loads are rising. I mean, you heard about that earlier from Dave. We know that the amount of power we're going to have to deliver is going up for a variety of reasons. Climate change is making things hotter. You know, air conditioning systems have to run longer. People who didn't used to have AC are putting AC in now. That's a big driver of load growth. But even more impactful is electrification of transportation and buildings. And we see a tremendous amount of new load, as we say, coming from those two factors. So here's where energy efficiency has kind of gotten out to a head start to help the department prepare for that. Over the last 7 or 8 years, we have actually reduced the amount of energy, kWh, that has been sold and delivered across the DWP grid by about 15%. And that freed up capacity, it now sits there ready to absorb these new loads we talked about, building electrification, transportation electrification. And we'll need to build more. That won't be enough for how much electrification we ultimately could get, but it gives us a good head start. So as we aggressively ramp up electric vehicles and building electrification, there's already capacity in the system to absorb that. Now that's delivered capacity. Now, what I haven't gotten to yet is, and this is where this connects into demand response and demand flexibility, is merging those power flows when they're needed. Transportation electrification, people typically charge at night when you don't have any solar generation at all. You might have some wind. And building electrification, that may run more during the day, it might run in the evening. So there's a lot of, as we move further into renewables, intermittent renewables, there's going to be a lot of need to sync up the power flows between when they're generated and when they're needed. And that's where things like both utility and distributed scale storage come in, but also demand response and demand flexibility. What loads can we shift? How can we shift those loads around the day? So there's a very unique and tight synergy between energy efficiency and demand response. And I'm going to briefly cover a few measures where we have that synergy already in place and what the snapshots and future is going to look like there. Next slide, please. Okay, so here's an example of the market for smart thermostats, which are applicable mainly to central AC systems. So we're going to do a drill down here. We've estimated that central AC units in the city of Los Angeles, which is our service territory for the most part, is about 850,000. Through various sources, we've been able to determine that there's about 180 smart thermostats in the market already. So smart thermostats allow, smart means internet connected, meaning it can be set up to take a demand response signal from us to adjust the thermostat if the customer signs up. So there's, again, 850,000 central ACs, 180,000 of which are connected to smart thermostats, 36,000 of which are currently enrolled in our demand response programs. So that shows you a couple things. It shows you there's tremendous potential to get more smart thermostats out there. There's tremendous potential to sign up the smart thermostats that are already out there for demand response. Next slide, please. Skip this one. Next slide. Okay, so here's where you see how we've been ramping up. We had about 20,000 enrollments in 2020. That was up to 30, you saw 36 in the previous slide, 37,000 as of 2021. And we're anticipating a much higher level of enrollment by the end of 2022. This is taking into account new smart thermostats that are aggressively getting pushed out, as well as going after the base of already installed smart thermostats that haven't been installed. So that's where you see we can have exponential growth, but we can also go back and sign up existing thermostats that are smart. They just haven't been signed up. The point I make here is that we're coordinating with demand response. We're partnering with demand response. we don't have to do everything at exactly the same time. And that's a key thing to realize, in scaling up these types of programs and measures, is you can't wait until everybody's ready to go before you do anything. We made sure from day one, when we were pushing out smart thermostats, that even if we weren't ready to offer them a demand response program or measure, the thermostats would be technologically ready for it at such time as that happened. And that's exactly what happened. We got 180 smart thermostats out into the city, and now we can sign them up. And of course, we try and, as we push new thermostats out, get them signed up from day one. But the point is, we were able to be strategic in how we pushed out a distributed infrastructure that may not have had every capability enabled from day one, but was backward compatible and could be enabled at some point down the road. And that's what you see reflected here. Next slide. So that was smart thermostats. That's residential and small commercial. I did want to talk about some of the commercial side as well. I think that's actually probably the larger audience we have on the webinar today. So we're in the energy management space and HVAC, as well as variable frequency drive controls for pumps and fans, and network lighting controls. And we have these projections of cumulative adoption. And again, an energy management system may not be hooked up to the demand response program from day one, but it can be hooked up to that subsequent at such time as either the program is ready or the customer is ready to take advantage of that capability of their EMS, their energy management system. And then you can see we start getting into, the chart on the left is the number of systems that we anticipate, and a pretty dramatic growth rate there from about 3 to 5,000 a day to 15 to over 30,000 by 2025. And the chart on the right is the cumulative gigawatt hours or megawatt hours that are coming from that we're saving in energy efficiency due to these measures. And so we're getting dual benefit. That's the point I'm making here. The utility and the customer, you guys, are getting dual benefit from having both an energy efficiency measure and a demand response measure. You get an incentive from us up front to do energy efficiency that are quite generous by California utility standards. That covers, that helps with the first cost of implementing the measure. But then, of course, you also get the ongoing savings. Those savings are kind of locked in because that equipment continues to deliver those efficiency results, those energy savings. Then when you sign up for a DR program with that DR enabled equipment, then you're also getting a benefit, as Hassan explained, from the demand response, from being part of a demand response program and responding affirmatively to utility requests and calls to drop load. So it's really synergistic. We've been working on connecting these programs for a good 5 or 6 years, and we've gotten a number of measures aligned to where they're effective today. And so that's an exciting place to be because these things take time to set up, and we sure wouldn't want to be setting this up from scratch now. So definitely kudos to Hassan and his team, working closely with my team on getting these dual benefit synergies into what we like to call a one-stop shop format for customer participation. And with that concludes my remarks. I'm happy to take questions as we get to the Q&A, and I'd like to thank everybody for attending.
Excellent. Thank you, David. And, just a point I wanted to underline, which you made very well, was, putting in place the capability, the technology, it can be tied together later, right? And I think some of what Celso might get into will speak to some of that as this is all done on a time continuum. So with that, we'd like to transition over to Celso Barcena with Heinz to provide the customer perspective. You've been active in all of this for a while now, And really appreciate you making some time to share your experience, and then we'll get into some conversation and bring David and Hassan back in.
Excellent. Thank you, David. Thanks for the opportunity. I was really happy to see the number of participants we have, and many of them are people that I know in the industry over the years, engineers who do the work like I've been doing over the last 20 plus years. So yes, we started working with the demand response program back in 2016, and that was at TIM 100, Santa Monica and Century City. And over the next few years, we had the opportunity to implement what we learned through our participation in the program at other facilities, including the US Bank Tower. And I'll be sharing some of our performance and cost reductions for the US Bank Tower on this presentation. Currently, I've been assigned to work at One Wilshire, and that's the picture you see there on the right. This is a data center, 700,000 square feet, a little more than that. And it's a critical facility. We operate several generators. We have a total of about 30 megawatts of power generation capacity through several generators that we have on site. Here we have opportunities to do some demand curtailment, but mostly the opportunities we have here are associated with energy efficiency and water efficiency. There's a lot of water that we use at this facility. So that's all work in progress. But let's move on to the next slide, please. Okay, so I'm kind of a nerd, I guess. I get really excited by looking at graphs, and I think this one here tells a really exciting story. This graph here was produced when we put together this as part of one of our demand response participations at the US Bank Tower. The two lines there, the blue line is showing what our KW use or demand was expected for the day. The orange line shows what the actual KW consumption was. And as you can see here, DWP had requested that we participated on a demand response event starting sharp at 1 p.m. And that is why this orange line drops abruptly there. So that's really good news. That means that our measures are taking effect and we're able to reduce the electrical load in the building. And we managed to keep it below what was expected all the way to the end of the event, which was at 5 p.m. So for this particular event, we were able to reduce about 300 kilowatts. And as part of our participation for that season, I think the rebate was about $15,000. Again, over the years, we've been able to increase our knowledge on how to apply this different demand reduction measures. I think for us as engineers or as a management firm, the key has been to pay attention to where our electrical use is. As you all know, most of the electricity is used in cooling the building, chillers, cooling towers, all of that. So that was the first step. And then the next step that we figured we definitely wanted to do was to make this process a little more automatic. We initially had our engineers running around, and I was one of them, going and trimming down set points and slowing down pumps and doing all kinds of manual adjustments on our BMS system. We were working with a Siemens system at the time. And this is good, but it is kind of labor intense. It was taking us anywhere from 1 to 2 hours to set all of those measures in place. We needed to be ready. And then obviously the challenge is at the end of the event, whoever is tasked with managing this whole process, this person needed to make sure that all of the set points were put back to normal. And often we realized that sometimes we were creating more problems than what we needed to have. So that and a few other aspects that we learned along the way kind of pushed us to make this process more automatic. Can we go to the next slide, please? There we go. So more graphs. So here, number one, what we managed to learn and to implement was to have an automatic system through the Siemens Apogee system at this particular site, where our engineers were able to schedule events ahead of time. So for example, if we get a request from DWP today or anytime this month, we can schedule it on a calendar, and this event will be triggered automatically. Even if our guys forget, if our engineers forget to do this, the event will still take place. However, that's just kind of like the easy part, that is making our jobs easier. But I think that the very exciting part here is what we learned in terms of potential energy savings, and more than that, cost savings. So as an example, back in 2016, DWP called us and they said, guys, we want you to participate tomorrow on a demand response event. So we participated, everything went well. However, the next day, we did not get a call from DWP, so we did not participate in any event, or we did not trigger any events. But the next day, we had a record high temperature in our area at the time, Century City, and we set a new record high demand with DWP, which has a ratcheting rate impact and an annual cost impact for the property. So as part of this whole exercise of participating in DR events, we are now intrinsically involved and knowledgeable and have knowledge of our rate structure, which for a lot of us is the A3 rate structure. I think that covers most high-rise buildings in the LA area. And in order to maximize the savings that we can achieve through DR, we need to understand how the rate structure works. So one of the first things the only things we learned immediately is that, guess what? We want to do demand response for ourselves because we can lower our costs. Also, as part of this analysis, we learned that for our properties, about at the time it was, I believe, 6 or 7 buildings that we were managing in LA, about 38% of our monthly bill is associated to demand costs. And we have the capacity to control those costs by changing how we operate the building. So what we did with the automatic demand response system is that we set an automatic threshold. Here is shown on line 1800, so that if my building at any point gets to that limit that I do not want to exceed, that is where I want my new record high to be. If I get close to that threshold, what happens is that automatically my BMS system determines that I need to start shedding load, and that's what you see here. So the blue line is showing where my electrical demand was. The dotted line shows where it should have been if I hadn't taken any precautions, right? So that was going to be a particularly hot day. That is shown on the red line. The temperature for that day went up to close to 90 degrees. And right when I hit the 1800 threshold, my demand dropped because my Siemens Apogee system started shedding load, and it protected me from setting a new record high. So I see the concept of having a demand response system that is automatic is kind of like having the computer watching and making sure that the operations in the building are appropriate, and that it also covers for any user error, which unfortunately we learned that at least 50 to 70% of the time when you set a new record high in your building is not necessarily associated with temperature. It's associated with user error. And I don't mean to speak ill of my people, the engineers, but it happens. You're trying to start the chiller at the optimal time for the day, or you have a chiller failure. How do you compensate for the spike that you are going to have to incur if you start your second chiller, right? So having an automatic demand response system allows you to compensate for all of those variables that are so hard to manage throughout the day. So here, let me show you the next slide. This is a bill, an electrical bill. This bill was for the US Bank Tower at the time, in 2019. After doing 1 year of automatic demand response that we implemented at the property, you can see here on the top left red square, those used to be my record high demands. So that used to be 2,500 kilowatts. After suppressing any spikes for a whole year, we managed to lower our ratcheting rate to 2,100 kilowatts. And that specifically translated to $50,000 in annual savings just by changing how we operate the building. So yeah, the incentives are great, but really that's just a tip of the iceberg. We learned the real savings come from having a demand response system that you're constantly applying and automatically triggering at your property. So there's a lot of details that go into this. There's a lot of studying that has to happen basically with the building data. But one of the key elements that I would suggest that anybody should have if they're interested in having an automatic demand response system is real-time monitoring of your electrical demand at your properties. And the good news is that hardware seems to be getting becoming more affordable. I was just looking the other day at implementing the same measures here at Pac Mutual, another Heinz property in downtown. We could install CTs on our mains for less than $2,000. So if you do the math quickly, just with one participation, for the whole season in that building, we could pay back for this investment in less than a year. And then the rest is just money that we get to save moving forward. So I'll be happy to share more information. And if anybody has any questions, please don't hesitate to reach out. And thanks for the opportunity.
Awesome. Thank you, Celso. And like the DR program itself, it's awesome to hear that the sort of hurdle in terms of cost for the hardware to really enable all of this has come down to really attractive ROI, and these types of examples are really really powerful. So I wanted to invite David and Hassan to also come back on the camera, and we've got a few minutes left to do a little more discussion and questions. If anyone wants to shoot those in through the chat, please do. But I will circle back on a point earlier that I think kind of ties a lot of this together, which is that, some of, and this is intentional, some of the DR measures that Hassan touched on are also incentivized through David's programs through custom performance or CPP. But, and this is where I want to kick it to Celso, David's team needs to see some projections, right? What do we think is going to happen if I go ahead and install these CTs, which we know are cost effective, but in order to be able to pay out, because they are a utility, they have to have some notion of what's expected to happen, right? And the durability of those savings. So Celso, I wanted to just ask you kind of how you've gone about developing some of the projections that you have done, and kind of how that helped you sell the project internally. And then I'll invite David and Hassan to jump in, and I'll follow up.
Absolutely, yes. That is very important, I think, especially for demand response. If you compare demand response to any of the other energy efficiency projects that we engage in, it seems a lot more abstract. It's hard to show where the savings are, because you don't have a new efficient light bulb, you don't have a new chiller or a new pump. It's more about how you are operating the building. So it's all about the data and how you communicate with your management company, with your team, and with your tenants, because also a challenge is to reduce costs, reduce demand, but not upset your tenants. We need to have happy tenants in our building.
Yeah, I want to come back to that.
Yes. So number one would be to do a detailed review of your historical demand in the building. I would say at least a couple of years, and you want to compare that to what the weather has been in your area. We found that initially we were trying to compare our electrical demand to the outside air temperature, which is a good index. That's a good measure. However, we realized that we were missing something, which is the humidity factor. So then we got a little more complicated. We got a little more into it, and we started working with enthalpy, the enthalpy in the air. We wanted to know how much total energy, so that includes temperature and humidity. So we realized that this was the best performance or index that we could use for our buildings. And that's how we've been calculating what the expected kilowatts should be given the weather conditions. And then from there, you then after doing a couple of trial and error runs, you can get a good idea how much you can reduce your demand on a very hot day. And with that, you can start coming up with predictions as to how much you expect to reduce your kilowatt and therefore your cost on a monthly and an annual basis. So something else that is, I think, important to touch on, the figure that I shared with you guys about $50,000 in savings, that was strictly ratcheting rate cost. There's another component, which is the monthly demand high. And that every month that you reduce your record high for the month, you're going to be savings, you're going to see savings on a monthly basis, right? And then once you keep your peak demand low for a whole year, then you're going to get a compounded savings that is a lot higher. So it's intricate, but it's very rewarding, and there's a lot of potential for savings there. But it does take some number crunching, trending temperature, humidity, and real-time kilowatts for your property. And then from there, you can come up with a good plan on where you think you can be and what you can achieve.
And it's really impressive that you guys, were able to do that in-house, that you had the ability and the resources to do that. I wonder if, did you consult any of your vendors, or, in other contexts, what do you see the role of a consultant or vendor in this process? And David, how often do you see sort of, customer generated analysis coming in to support an application versus a vendor? And I'm not advocating one way or the other. I'm just thinking for those who may be saying, wow, I wish I had a Celso, to do this for me, what other ways to kind of get at this?
I would say in general, first of all, we're open to any pathway that brings the project in. But for the most part, it's the larger, better resource, more sophisticated portfolios of properties that will have, an asset like Celso, who can do this type of analyses in the process of bringing a project to us. Generally, it's usually a vendor or a consultant who's working with or for the property owner, property manager. In many cases, they're the ones who would do the installation work, and so they're bidding a project, and we try and keep them very appraised of our programs. We run workshops for CPP, and I'm sure DR does as well, for the vendor community all the time, so that they can put together project proposals, do retrofits, and bring a complete package of benefits to the customer. Just the energy efficiency, you install it and then just kind of forget it, because you've installed a more efficient device, and every time you use it, it saves energy. That's why you get a one-time incentive on energy efficiency. Demand response demands that you continue to respond to pricing signals and requests to drop demand. So that's why it's paid on an ongoing basis. We wouldn't pay up front and then you decide to, not respond 8 out of 10 times. So it's more of a pay for performance type of incentive. But the beauty of it is you getting both of those benefit streams from one particular product. And that's where the vendor, either a very sophisticated facilities group like what Celso has, or a vendor who is smart about how they bundle the benefits of the product that they're selling and knows the utility programs to build that into that business case and that proposition, really comes in handy to make these projects happen.
Yeah, that's I agree with that 100%. And I think, like always, there's always challenges with finding the right people for the right project. And I did rely on our partners, specifically for hardware and maybe installation of that hardware. But I do, maybe there's more people out there, but in my experience, there's a need for support when it comes down to data analysis and understanding how buildings operate, and also specifically for demand response, because like Hassan said, let's say you subscribe to the program and you think you can commit to 150 kilowatts, but soon after you realize, hold on, I can actually reduce my kilowatts by 300 or 400. For example, when at the US Bank Tower, we initially subscribed to, I think it was 250 kilowatts. And by the time we were done with that project, we were up to 400 kilowatts reduction, right? So there's a lot of ongoing learning that needs to happen, but you can only achieve this by keeping good records and having the data to support this. And yes, I think it's important either to have somebody in-house or find a vendor who can help you do this so that you can maximize that potential.
Mhm.
Yeah, it takes a little bit of working. Another one that I know, David, I'm sure you guys work with this, but I see a lot of opportunity on start-stop optimization. I know it's an old concept and most people mention it, but I have yet to see a building that when I arrive has a system that is actually working well, and there's a lot of potential for savings there. So that's one. And yes, again, I think the hurdle there is not the hardware, but it's having the person who can usher and maintain the system, because it's not a one-time deal. You need to set it up and you need to maintain it and maximize it. It's an ongoing process.
Right. And that technology to help enable that, so we don't miss a day or.
Well, and I think also a lot of it depends on knowing the building and adjusting the set points. There's so many set points, you need to be thinking about outside air temperature conditions, when my tenants arrive at the building. There's a lot of different inputs that you need to massage, and then you'll get it working perfectly. And then the last one that I've been working with lately is demand-based services, meaning activating your air conditioning when the tenants arrive at the property, right? And there's a lot of potential, and there's a lot of money invested already by building owners in Los Angeles with occupancy sensors, network systems. Unfortunately, there's no meshing or connection between my lighting occupancy sensors and my VAV boxes. The system is there. It is able to talk to each other. It should be able to communicate. It's just finding the vendors that can help us integrate all of those systems to maximize those savings. There's a lot of potential. There's a need.
Thank you, Celso. And I realize we're just a couple minutes over, so really appreciate all of your time. I would encourage folks to check out our provider list at betterbuildingsla.com. We've got a list of qualified local audit and RCX providers. And I'll always end with a quote, but the great John Wooden said, flexibility is the key to stability. Only constant is change. So thank you guys again, and appreciate everybody tuning in. We could go all afternoon, I'm sure. Take care, everybody.
Thank you.
Everybody.